Our lives would be inconceivable without technology. Yet machines are also a threat. Will they replace us? Will their effects destroy our world? But the present we live in was someone else's future. These passions and concerns about technology have a fascinating history. We need to go back to a world, the Victorian world, when machines seemed like angels and more often like monsters. I want to show you some of the greatest engineering wonders of the 19th century. They were startling, inspiring feats of technology which posed deep philosophical questions. They were cutting-edge scientific advances which challenged faith in God and undermined our place in the universe. They ask us, what does it mean to be human? How was the universe created? What does the future hold for all of us? A couple of hundred years ago, building giant machines needed a technological breakthrough, which is why I've come to Coalbrookdale in Shropshire. It's a quiet, rural scene now, but at the beginning of the 19th century, a painter called Philip de Lautherberg came here, and this is what he painted.
Lautherberg's vision made Coalbrookdale look like hell. The 15-mile valley of smoke, brimstone hanging in the air. He was gazing at furnaces, iron foundries, fueled with coke and ironstone. This painting has become iconic. It proclaimed the arrival of the mechanical monsters of the 19th century. Coalbrookdale's great furnaces forged the Industrial Revolution. For Lautherberg and other visitors to Coalbrookdale, what they were seeing was a dramatic combination of a volcanic explosion and the power that engineering and machinery could exert over the forces of nature.
The furnaces were using a new process, harnessing the power of high-energy coke. They made it possible to construct vast machines.
This great steam hammer, for example, could simultaneously crush a railway sleeper. It could pound iron into fragments, but it could also be controlled so precisely that it could crack the shell of an egg without crushing it.
These new machines could be terrifying. They had the capacity to rip off workers' arms and legs, and they dwarfed life on a human scale. In fantastical cartoons of the period, newfangled machines have transformed daily life. They can help you travel fast, you can even fly. A steam-powered engine can give you a shave, but it can also go horribly wrong. In this strange new world, the distinction between human and machine seems to blur.
Increasingly, humans were seen as machines. They were treated as though they were engines. They were cogs in a vast technological system. And at exactly the same time, machines seemed increasingly capable of everything humans could do. So there were critical questions right at the heart of Victorian culture. Are humans no more than machines? And are machines going to replace humanity itself?
This was the question at the heart of my first mechanical monster. What does it mean to be human? It was the creation of Charles Babbage, mathematician, inventor, entrepreneur. He thought that machines held unlimited potential, and it was a deeply practical necessity of the time which set him thinking.
Babbage's world was dominated by an avalanche of printed numbers, mathematical tables, logarithms, trigonometric functions on whose accuracy the commerce and trade and navigation of Britain completely depended. This is the Nautical Almanac, published each year by the Board of Longitude, whose mathematical tables instructed mariners on their position. Each digit in these tables was calculated by human computers. Any error in their calculations was fatal. Examining these tables, and to his horror, finding scores of errors, Babbage expostulated, "I wish to God these calculations had been executed by steam."
Babbage had a keen eye for a commercial opportunity. He lobbied the British government and obtained thousands of pounds in funding to try to make his ideas a reality.
Babbage's lifetime ambition was to build a series of extraordinary calculating machines. His plans were exquisite, detailed masterpieces of Victorian science and technology. First, a difference engine with 8,000 parts that would allegedly make error-free tables, and then an even more ambitious analytical engine, a general-purpose computer. Babbage's great calculating engines were based on the layout of what he understood as the factory. And to modernize, the reason these machines are remembered is because they look like the ancestor of everyday computers now. But that's not why I'm interested in them. They matter to me because they raised fundamental philosophical questions in the great theological crisis of Babbage's own time.
Babbage never managed to build a full-size engine, but parts of it were built, and one of them is held in Cambridge, in a place very close to my heart.
So we're here in the Whipple Museum, which is where I work. In fact, my office is just upstairs. And this is a very special moment for me because this is a fragment of Babbage's difference engine. It's normally shown behind glass. This is the first time that I've ever been allowed to touch it. And that's a real treat.
Every tooth on every wheel represents a number. As it's cranked by hand, they mesh. Each interaction represents a new calculation. Bigger machines had the potential for greater power. Although Babbage never managed it, the Science Museum in London has built a full-size difference engine based on Babbage's original drawings. It works perfectly, carrying out calculations to an accuracy of 30 decimal places. But Babbage dreamt of an even bigger machine. It would have been capable of memory, of calculation, of prediction. And it was this which would raise profound and troubling philosophical questions in the decades ahead.
For Victorians, it was the powers of human reason put into humans by God that showed the superior status of humankind. And what Babbage's machine threatened was that these were no longer the prerogative of humans alone. Rather, any well-programmed machine could, with unerring accuracy, emulate and perhaps even surpass what humans could do.
Could science create a soulless automaton capable of thought, which could perhaps one day even replace human beings? This was the spectre raised by Babbage's extraordinary technological dreams. For Victorians, science was challenging their very sense of who they were and where they came from. My next mechanical monsters were built by men grappling with one of the greatest questions of all: creation. Most Victorians believed that God designed the world and everything it contains in just a few days. Yet real-life monsters were rising up to challenge that idea.
Here in Cambridge's Sedgwick Museum, there's a collection of more than 1.5 million fossils and rocks covering the 4 billion years of the history of our planet.
The 19th century was the first age to dig up, name, reconstruct, and puzzle over dinosaurs.
Dinosaur reconstructions were some of the most remarkable triumphs of Victorian engineering. Often, Victorians had to work with really very few fossil remains. And what they achieved, with an amazing combination of historical imagination and technical expertise, easily rivaled the other great mechanical marvels of the 19th century. These fossilized bones proved that the Earth had a history, and a strange one, since they were the relics of beasts no longer alive. Somehow these animals had become extinct in dramatic ways. This was a history that fascinated the Victorians, but it also posed genuinely serious, genuinely dangerous threats.
It was this potent mixture, the fascination and the threat, which drew thousands of people to a park in suburban South London. Opened in 1854 in the grounds of the Crystal Palace exhibition, it offered unsettling visions of the past. A mechanical menagerie of monsters rising up from the waters.
This is a megalosaurus, gigantic beast that originally roamed southern England in the Middle Jurassic period. This model was built here at the Crystal Palace by Benjamin Waterhouse Hawkins, one of Victorian England's leading sculptors. The idea was to show the monstrosity and the nobility, the design and the horror of these ancient beasts.
Creating these monsters was an enormous engineering challenge. Their construction used hundreds of tiles, bricks, cement, broken stones, iron hooping, and central iron columns.
Just as Hawkins' dinosaur models were being completed, they staged a dinner inside the mold of this iguanodon. About 24 people huddled together. Drinks were taken, songs were sung. The jolly old beast is not deceased. There's life in him again, they chortled. According to Hawkins, they made so much noise at the dinner that it was like a herd of iguanodons released into the Crystal Palace grounds.
The impact of these dinosaurs on the mid-Victorian psyche was immense.
It was like time travel. Monsters like these had once roamed the earth. Many imagined that the dinosaurs must somehow have lived between the time of the creation and the time of the flood. According to some visitors, these great beasts had been simply too big to fit on Noah's Ark, and so they'd been washed away with the flood.
The men who built this park were convinced that dinosaurs were an example of God's creative power and purpose. Yet soon, these ideas would be rudely challenged.
Within 5 years, Charles Darwin would publish his incendiary work on the origin of species. The story was no longer that dinosaurs like these had become extinct because somehow they'd been too large to fit on Noah's Ark. They'd been extinguished because of the Darwinian struggle of all against all for scarce resources. The fight was on between creation and design and evolution and natural law.
Scientific theories like evolution were attempts to explain the miracles of creation. Just as dinosaurs rose from the ground, so astronomers seemed to be finding strange beasts in space too. My next mechanical monster became a weapon in a battle to explain their mysteries and answer the question, how were the stars and planets created?
This is the Orion Nebula as it was sketched by Victorian astronomers looking at this celestial object through their very best telescopes. And what they drew filled them with horror. For them, this was a monster with a curling lip, a hideous eye, the atmosphere around it full of terror, hatred, tyranny, revenge. The nebulae were the chief building block of a dangerous new theory we now call evolutionary cosmology. The nebulae, so it was argued, were nothing but clouds of luminous gas. And under the action of natural law, without any divine intervention whatsoever, these nebulae were spinning and condensing. They formed stars and suns, our sun and our Earth. For many, this stank of heresy, and the idea of this nebular evolution had to be strangled at birth.
A machine would have to be built, a monster to conquer a monster. This is Birr Castle in County Offaly, Central Ireland, the ancestral home of the Earls of Ross. In its grounds, what looks like a smaller castle. But in fact, it's a 56-foot-high mechanical monster built to try to resolve the mysteries of the nebulae.
This is the great telescope that was built here between 1842 and 1845. It was the largest such instrument in the world, a status it would maintain right through the rest of the 19th century and well into the 20th. And it was with this machine that some of the fundamental problems of evolution, of science and belief, of religion and of creation would be resolved.
It soon came to be known as the Leviathan, and it was built by the third Earl of Ross and paid for with cash from his wife, Mary Ross. Lady Alicia is their great-great-great-granddaughter. She spent years cataloguing the castle's archives, including some remarkable photographs taken by Mary.
She was a pioneer photographer, and but for those photographs, we wouldn't have a record of what exactly it looked like because we have no working drawings. And of course, all the metal work was melted down in the First World War. So the telescope was very complicated mechanically. It's got underground tunnels in order to get all the pulleys and the counterweights. And those photographs are incredibly useful when you're trying to restore and rebuild.
And they also include, very often, this is one of the reasons I love them, there's the family.
There's always a family in it. Mary Ross, on top of supporting her husband in his great project, she also had quite a lot of children. Sadly, only 4 survived. And her kids were all brought up in the workshops. From an early age, they were tutored in the workshops. The fact that they're involved in the telescope, I think, is wonderful.
It gives an impression, which I think is really interesting about this heroic engineering achievement, that it's a domestic achievement.
Absolutely it was, and they were very much in the heart of it.
Running the telescope was heavy engineering. Because of the Irish weather, the mirror tarnished really badly, so it needed to be repolished in the workshop up at the castle. And then after polishing, a team of 6 would have to bring it on a cart all the way from the castle. It weighed 4 tons, and the men would then handle it really carefully down to the working end of the telescope. So it was from this platform that the astronomers would make their observations with the giant telescope. In order to approach the tube, it was necessary to turn a winch and move the platform so that you were in position. We're in the middle of the Bog of Allen in central Ireland. Much of the sky would be clouded with peat smoke. That was the local fuel. It rains an enormous amount. And not only that, but the Great Telescope can barely move east or west. It relies on the motion of the Earth to bring any particular celestial object into its field of view. And if that happens to be a night when it's cloudy or raining, then you've lost it, maybe for months, maybe for years. So we can see that getting reliable observations out of the telescope was a matter of real difficulty and considerable controversy.
Lord Ross had built the telescope largely to demonstrate the power of Victorian technology.
But there was another equally important figure in the story, in the life of the telescope. That was Thomas Romney Robinson, priest, master astronomer, very close friend of Lord Ross and frequent visitor to the telescope. For Robinson, nothing less than the fate of Christianity was at stake. Robinson loathed evolution. He loathed the nebula hypothesis. He thought the idea that there was luminous fluid somewhere in space from which all planets, all stars, all life had somehow emerged was a dangerous, filthy heresy. And what he set out to do was to use the telescope as a weapon in the fight for the survival of religion itself. So in February of 1845, Thomas Romney Robinson joined his friend, Lord Rosse, here at the telescope.
Over the next few months, they pointed the telescope at nebula after nebula, and Robinson started making announcements. He claimed nebulae were not evolving. They were just made up of stars, as he'd always hoped.
But there was one crucial exception: the Orion Nebula itself. It held out, it resisted the attentions of the Irish astronomers. The weather was terrible, their view was obscured by clouds, the nebula was in the wrong position even to be observed by the monster machine.
It took more than a year, but finally Robinson announced
a triumph. The Orion Nebula, he said, was resolvable. It seemed as if the nebula hypothesis, all the evidence on which it had been based, the main claim for cosmic evolution, had been destroyed in one blow, and true religion and the science of creation saved.
It seemed that the nebula hypothesis had been laid to rest, perhaps even discredited by the Leviathan telescope. But then a tiny David came along to slay a Goliath. It happened not in a nobleman's castle, but in the much more humble surroundings of Tulse Hill, South London. Here, a keen astronomer and former draper called William Huggins designed his own instruments and pioneered a new form of astronomy, astrospectroscopy, the analysis of light itself. Dr. Jen Gupta is an astrophysicist at Portsmouth University. She's an admirer of William Huggins and even more of his wife Margaret, who worked with him for most of his career.
I think for me, the fact that they were so devoted to astronomy is what fascinates me about the Huggins. I mean, there were stories of Margaret actually got a spectroscope for her wedding present from a friend. They named their dogs after famous astronomers from the past. And that devotion to the science and the fact that they pretty much invented this field of astrophysics, of taking those observations from the sky and sort of marrying that with the physics that we're doing here on Earth, really opened up this entire window for future astronomers.
When you pass light through a prism, it breaks down into its spectrum, its different wavelengths. So William Huggins developed instruments you could attach to the end of a telescope and capture the spectra of distant objects.
This is a spectroscope designed by William Huggins himself. What Huggins did here was let the light enter through this slit, pass down the tube to a prism there to split up the light from the celestial object into its spectrum. Now, what chemists knew in the middle of the 1800s is that there's a fundamental difference between the spectrum of a gas and the spectrum of a star. So this small but exquisite instrument would answer one of the great questions of 19th century science.
That's the theory, at least, but it's a hugely complicated challenge in practice, even using modern technology. This is Clanfield Observatory in Hampshire.
What we're doing now is essentially the modern day version of what the Huggins would do. So they would have the spectroscope on the back of their telescope, but instead of having a digital camera, they would have just had photographic plates. So the light is going to come down this tube here into a prism and a diffraction grating, and then the spectrum will actually be taken with this camera at the back here.
The first target is the star Arcturus.
So what you immediately see is the continuous rainbow going along. And this is pretty much exactly what William Huggins would have seen when he pointed his telescope with a spectroscope at a star.
The next step is to find a nebula. But in typically difficult British conditions, there's a huge amount of atmospheric disturbance.
We pointed the telescope at the Ring Nebula for a few minutes to gather light from this faint object, but this is the best we could get. We've got a very faint blue emission line coming through, but it's not great because the viewing conditions today weren't optimal. And I think this shows how hard it is still today to do this kind of science, to use a telescope even of this size. It's still pretty tricky to get a spectrum.
Fortunately, they have this, the spectrum of the Orion Nebula, which they've photographed in better conditions, and it's clearly very different from a star. The Huggins spent decades studying nebulae like this and established that many nebulae were composed of gas, not stars. We now know that they're star nurseries, gas and dust condensing and evolving to form stars and planets.
Like dinosaurs, nebulae had been turned into signs of evolution. And this beautiful but rather humble instrument, managed by a retired draper living in South London, had somehow proved that the lessons of the great telescope at Burr were misleading and false.
Lord Rosse's telescope did go on to make many stunning discoveries, such as the spiral nature of some galaxies, but the true nature of nebulae had somehow eluded it.
So what had gone wrong here at the Great Telescope? The astronomers in Ireland were working right at the limit of observation in really difficult conditions. And as one of them admitted in the wake of Huggins' observations, the eye may be influenced by the mind. You see what you desperately want to see. And mechanical monsters like the Great Telescope, however magnificent, can also be really treacherous when humans take control.
My next mechanical monster was built to tackle the fearsome, destructive side effects of progress. But this machine will give us profound insights into one of the biggest questions of all, the fate of the universe. By the middle of the 19th century, the population of London had risen to well over 2 million people. And with no proper sewerage system, all their waste drained straight into the River Thames. The river became known as Monster Soup.
Hello. So I'm here with my friend Elizabeth Pisani, who is authority on epidemiology and is fascinated by the deeds and sufferings of mid-19th century London disease. So if we'd been here on the banks of the Thames looking out at the Palace of Westminster in the 1850s, what would it have been like? What would we have experienced?
Well, first of all, we'd have been doing this because it was a cesspool, essentially.
And people were dying.
And people were dying. So there were massive cholera outbreaks every few years. The first case of cholera in this country arrived in 1831, 20,000 deaths within a few months. And then there were periodic outbreaks every few years. But at the time, it was very firmly believed that cholera was caused by the stink,
right,
not by the water. don't forget that at the time, these beautiful embankments along the Thames weren't there.
Yeah.
So it was much shallower, it was much flatter, it was much muddier, and the effluent, to put it politely, was sort of trailing down the sides right up to the Houses of Parliament there. And actually, over the years, it got stinkier and stinkier, and 1858 was a particularly hot year.
So that was the Great Stink.
The Great Stink of June 1858.
Tell me about the Great Stink.
I don't know how to describe it better than the people of London described it at the time, the Great Stink. So there was this absolutely appalling smell rising from the river, so appalling that Parliament actually had to shut, which is something that hadn't happened before. Right. And suddenly they were, okay, this is coming a bit too close to people who are coming down from Hampstead or who are coming from their grand palaces in the West End are now actually rather closer to this stink than they previously had been. So it would have been a pretty unpleasant place to be.
Now sufficiently motivated, Parliament voted to fund an astonishing sewage system. It channeled the waste downriver towards the sea. 500,000 gallons of effluent were sent eastwards every day.
These vast volumes of sewage were brought down here to Erith, about 15 miles downriver from London. The idea was that the sewage would be pumped up into huge holding tanks and then released at high tide into the Thames and disappear down to the sea. The great engines that did the pumping were housed here in one of the most remarkable buildings of mid-19th century Britain.
Crossness Pumping Station is an outrageous grab bag of architectural styles. It has arches and pillars reminiscent of a medieval cathedral. It boasts ornamental cast iron work, its elaborate designs befitting a Byzantine palace. All of it just to house these giant steam-driven pumps. There were originally 4 engines running in this building. One has been restored to give an idea of their scale and power.
The steam engines were the heart and soul of the system. And magnificently, each of them was named after a member of the royal family. The Queen, the Prince Consort, her son, Albert Edward, his wife, Alexandra. This monster is the Prince Consort, the largest surviving rotative beam engine in the world. Victorians thought that cleanliness was next to godliness. And so it was inevitable that a sewerage pumping station would turn into a cathedral. This cathedral, with its amazing designs drawn from medieval architecture, from Venice, from Byzantium. The idea was that these vast engines had surpassed all the achievements of past civilizations. Mechanical monsters became the signs of a new modernity. The Cathedral of Sewage became something of a party venue for the Victorians. Dinners were held here in which bread rolls were thrown and slightly too much alcohol consumed. But every party ends with a hangover. Just beneath the surface of this engine house was a vast sea of London's sewage. Above all, something haunted Victorian technology, a threat they feared more than anything else: waste.
It all started with an engineering puzzle. Scientists at the time were trying to work out how to make steam engines more efficient.
All steam engines, including this amazing, really early experimental locomotive, rely on one simple principle. Heat travels from a higher temperature in the boiler to a lower temperature. And as it flows, it's turned into mechanical work. The locomotive moves. But even the most efficiently designed machine has a limit on how much work can be extracted from the heat. Some of the heat seems just to get lost, the work no longer available. William Thomson, brilliant young Scottish physicist, later Lord Kelvin, turned this into a universal principle. He realized that however ingeniously designed any machine was, there was an absolute limit on the amount of available work that it could develop. He called it the universal tendency to dissipate the amount of available work. Like any good Scotsman, he hated waste. He loathed dissipation. But what Victorians of the mid-19th century learnt was that the amount of work in the world from which they could make a profit was inevitably on the decline, and that their world was doomed to decay.
It's known as the principle of entropy, or the second law of thermodynamics. All processes move inevitably towards chaos, disorder, and waste.
Underneath the great Victorian optimistic vision of progress and a bright future, there was a deep and dark undercurrent of pessimism. Living on a planet now revealed as unimaginably old, in a universe extraordinarily vast, with all sign of divinity gradually being effaced, Victorians confronted the possibility of inevitable decline and decay. That on the one hand, their machinery would take them over, that mechanical monsters would rule the roost. And yet on the other hand, that machinery, that technology that had given them command of the world would go to rack and ruin. Deprived of energy, without any source of work, the 19th century confronted its own elimination.
My final mechanical monster embodied all these hopes and fears. It's perhaps the strangest tale in all of 19th century science and technology, a machine which never existed except in the heads of its creators. It was the brainchild of one of my favorite writers, a budding genius then at the very beginning of his career.
Herbert George Wells was a young science student who'd made a thorough study of the problems of evolution and physics. He was absolutely up to speed with the cutting-edge problems of late 19th century science. And he began to think about how to reconcile the problem of progress and the problem of decay, the future of the world and its end. And he turned those problems into an extraordinary scientific romance.
The Time Machine, published in 1895, is the story of a man who invents a device that transports him through time. It's a meditation on the future of science, civilization, and humanity itself.
Wells's story, The Time Machine, with its grim vision of a cosmic and industrial future, made his reputation. But what's much less well known is that he became involved in an extraordinary scheme to build a machine that could convey the experience of traveling through time.
What I want to do now is actually try to reconstruct how this strange machine might have worked. To do it, I'll need the darkness of a studio and the help of two technological wizards who know this extraordinary story inside out.
Hi.
Hi, good to see you.
Hello. Now, I've invited you here today, your world experts, on the details of that story, Stephen Herbert and Jeremy Brooker. In 1895, in the aftermath of Wells's publication of his story, The Time Machine, something absolutely remarkable happened, something which has always really obsessed me because it's just so dramatic and exciting, which is there was in London a scheme to build some kind of device that would evoke, that would conjure the very experience of time travel. Stephen, I'm really happy that you're with us today because you know so much about one of the key figures in this story, the man who really collaborated with Wells. His name was Robert Paul.
Robert Paul was an electrical instrument maker in the really new industry of electrics when he read The Time Machine. And he thought, this is perfect. I can integrate...
So he read Wells's story?
He read it as it was pretty much when it was published, probably, yeah. So he contacted H.G. Wells and said, I've got an idea about your story.
What they were interested in, so I understand, was creating the experience of travelling through time and getting an audience who would pay quite a lot, presumably, to go through that experience. And the technology that would allow them to do that was the technology of the magic lantern.
The magic lantern was an extraordinarily popular attraction in Victorian Britain. Lanternists were the entertainment showmen of their day, drawing huge audiences. And people had them in their homes too. Jeremy Brooker is chairman of today's Magic Lantern Society.
It looks amazing. How does it work?
Well, it's a simple device, essentially. There's a wooden box at the back, which has a very bright light inside it. There's a slide. Then the light passes through a tube, through a lens, which you can focus onto a distant screen.
The images are generated by complex moving slides. This is a model of the solar system. Jeremy's lantern allows him to project 3 slides at once.
You have a background image like this one, and then you can add an effect. So here we've got light coming on in the cottage window. And then the third lantern is adding another effect, which is snow falling. And you can imagine with music and perhaps a bit of narration, it can be quite a magical thing to see.
These were shows that became very absorbing for the audience. It's
Exactly
an extraordinary combination between engineering, nature, entertainment and science. And it's also pretty sweaty, I imagine, because this must generate a huge amount of heat.
Tremendous amount of heat. Nowadays we use LED bulbs to protect the slides, because in those days it would have been burning gas, which is why it's got a chimney on the top to take the heat away.
So these were dangerous. These were basically factory chimneys burning incandescent gases that could easily blow up, and they were in the middle of the audience.
There are really appalling descriptions of accidents from the gases mixing and exploding in the middle of the auditorium, because oxyhydrogen is essentially a bomb.
Right.
And the result's pretty catastrophic.
Right. So, a monster as well as fun. Robert Paul didn't just plan to use a magic lantern. He was busy inventing a brand new form of technology. By 1895, it was known that showing consecutive photos could give the impression of movement. But film was only available in boxes for one person to look into, a so-called kinetoscope. The race was on to project film onto a screen so a large audience could see it. Stephen, amazingly, we're very grateful, has built for us a version of the very projector that Paul must have been working on.
Yeah.
So talk us through how this device works.
I've got this 1895 lantern, which is basically a magic lantern of the period. He would have had, we know, an electric arc lamp. So he would have used electric light, which was actually brighter than the other options at the time. I've got a German mechanism, which is a star-cross mechanism.
Yeah.
And that's very close, not exactly, but very close to the sort of mechanism that he used at the time, and it's of the period.
What's that for?
It turns the sprocket intermittently. If you just roll the film through, it's a blur on the screen. And then on the other side of that cross would have been this thing, the sprocket, teeth on it, which pull the film down. And in fact, if you went to a cinema before they went digital, it's exactly the same format.
Yeah.
What I've done here is try to give an idea of, as you say, exactly where he got to, which is he hadn't got perfection, it will be a few months yet, but he was getting there. He knew he could do it. Should we give it a whirl and see if anything happens?
Oh, absolutely. I can't wait.
Yeah, well, OK, let's see. Now, you saw there that it was very out of focus.
Yeah.
So that's one of the things he's got to get right. But I can see him in his workshop thinking, lots of work to do, another 3 months, but we're getting there. It's going to work. It's going to happen.
Yeah. What we're looking at, of course, is the birth pangs of cinema. And Robert Paul is now considered a technological pioneer. But there was one final element to the time machine: movement.
In putting together a machine that could give the impression of traveling through time, Wells was thinking about the most advanced technology of his age. And I think one of the machines that he was thinking about was this, the bicycle. The bicycle was cutting-edge technology in the 1890s. It's no coincidence that in the very months that Wells published his story about time travel, he was learning how to cycle.
I believe Wells must have been inspired by this experience, the world rushing past you. So I think this is how the final idea for the time machine came together. It would combine magic lantern images and the new idea of film. But Wells also described time travel as being disturbingly kinetic. Excessively unpleasant, he said. Headlong motion, a switchback ride, the sense of an imminent smash. And so their idea was to put the audience in a room with projected images, but seated on moving platforms, to give them that horrific sense of being shaken forward into the future.
The machine was never actually built, so we can only speculate what an audience might have seen. Using original magic lantern techniques, Jeremy Brooker has created, especially for us, a journey into the past and future. In the novel, the time traveler is carried into the future. Humanity has evolved into two separate species. The Eloi, descendants of Victorian aristocrats, lazy, ineffectual, effete. And the Morlocks, the descendants of the oppressed working classes who have devolved into beasts and prey on the Eloi. Then the time machine travels even further into the future to find the Earth reduced to a beach with monster crabs crawling everywhere, and the sun is dying. Wells' bleak vision was based on his understanding of late Victorian science, the threat of evolution and of universal decay. Robert Paul never did build his time machine, but he became a central figure in early British cinema, making extraordinarily inventive, rather joyous films. Our lives today are dominated by technological concerns which started 2 centuries ago. Will machines replace us? Will their effects destroy us? But our response has to be very different from the Victorians.
For them, faced with a whole series of crises, machines, while they produced those problems, could also, in principle, solve them. We've perhaps lost that optimism and that confidence. We feel less secure with the technologies that we have inherited. The crises of our own epoch need to be confronted as we deal with our own mechanical monsters.